Okay. It was this whole transformation thing, up, down, left, right. Right? We did families of graphs, just moving things up, down, left, right. It seemed to go pretty well. Let's see what you got. Down at the bottom, 115. Check them. Yes, them. Yep. Regular or extra crispy? Yep. Okay, remember this idea was whether something is in or outside the parentheses, whether it's positive or negative, and then you just say it. We even had a nice little cheater chart for it. Okay, if there's nothing there, how about, oh, Frank, you were cross-eyed. Can tell my lunch crew must have been up here banging away at something. They were all arguing about fries, and there was a chart, and I don't know. So, okay, again. Now, this whole lesson was just about lines and parabolas. So we only had to look in two spots. Did 14 kind of throw you for a loop because it was written different? Okay. Just take your two terms and swap them. Okay. Then a little bit of that word stuff. They say we have a parent function, it's going to do these things. So this one was a little bit backwards. All those other ones, they were saying, here's the equation, what happened. Now we had to do some thinking. Here's what happened, what's the equation? So, any of this stuff got questions on? Okay, down to the bottom. They ask, is this going to be only a vertical shift? Am I only going to move something up or down? And the part that ruins it is there's a 2 in front. That gets to a different type of transformation. We didn't really talk about it, but it's called a vertical stretch. See, if this is the parent graph, if I move that thing up 3, it should be there. But the actual line that we're going to have is going to be twice as tall. Okay? It's got a vertical stretch to it. So no, I can't just shift it up and be done. In fact, do I have thing? Do I have thing? Oh, I thought I still had silly putty. It's really good for showing stretches and compressions and how they relate. You ever played with silly putty? You do the picture thing on it. You take the silly putty and smack it on a paper. Bam, you got a picture. Okay, you can take that and stretch it vertically, or maybe you've just played around in a Word document in Microsoft Paint, old school, where you just grab a picture and you stretch it, right? That's what this is. 2x plus 3 is when I take that line, move it up 3, but then I also stretch it twice as tall because now the slope is up 2 over 1 instead. Okay, so I can't just say, no, it's a shift and I'm done. I've got Play-Doh. I don't have silly putty. We have Play-Doh and we have Flarp.
Don't try stretching Flarp. I did that at home.
I don't touch that stuff. It feels slimy. So, no. So, we need a daily quiz. 3.6. You know when you see a word and spell it too many times and it's not a word anymore? I've been having issues with the word families for like the last 3 days. Is that right? It doesn't look like a word anymore. All right. Families of functions or families of their graphs. I'm going to have you do two things. Part A, I'm going to say y equals I would like you to tell me what transformations happened and what the parent graph was. For part B, there's your parent graph. Nope, not even that. There we go. Now you got to know your vocabulary too. Go, go. Okay, you tell me those four things. Tell me the parent function and its transformations. Suppose I can write that. Okay. You write those things, give me 3 minutes.
Or motions.
Anyone still going? I sound like a puppy squeak toy. You think that's bad? Try teaching a room full of teenagers when you have the hiccups. Sucks. No one takes you seriously when you're in the middle of a lesson. So, okay. We'll give it about a minute. I'll let you all in on this weekend. There's also, well, weekend, tomorrow. If anyone's interested, we got Game Club Geekathon going again. Come hang out. Most of it is I got a crew of about 16, 20 kids who are doing a Magic tournament, but then off to the side there's going to be another 15, 20 kids just playing games. Usually someone brings Smash. One kid keeps bringing his PC, got VR.
I really got to talk to my mom because I told her about it last time you mentioned it to me.
What? Yes. Drink upside down if you can.
Oh.
It seriously, it forces you to work against gravity, so it resets the esophagus. Yeah.
Or just ask her what color
No.
are elephants.
It's a pre-release tournament. You build with what we give you. Okay. No. We must math now. All right. Bud, this should have been like, we've got enough time. Okay. Either we know it or we don't. It's got a squared in it, so the parent function is x squared. That's it. If you had, did anyone say verbally instead, like write quadratic or parabola? Also cool, okay? So if you had said quadratic or parabola or just written y equals x squared, all of those, that is your mathematical daddy, okay?
I put down quadratic for like whatever ones were on the homework.
Yeah.
Right?
Yeah, that's fine. Okay.
I just found it on example too.
Yep. And you got to remember, I'm trying to like downshift transformations from Algebra 2 and pre-calc. So we're used to just writing the equation instead of saying the words. But then we say the words before we write the equation just verbally as a class. So, the transformations. Okay.
Two to the right.
It's inside the parentheses. Inside the parentheses is left, right. And because it is -2 and it's in bass-ackwards land, we're going to shift the opposite of what it says 2 units right. Where's that little cheater chart of ours? Remember? We should all have that little cheater chart that says with our parentheses, if it's positive or negative, if it's inside or outside, tells me if it's inside, that's left and right, and it's bass-ackwards. If it's outside, then it's up-down, and it's regular. Okay? That little cheater chart. That's why we made it. Also, plus 13, positive 13 on the outside tells me I will shift 13 units up. Okay. The parent graph is a line. So what does that look like? Like as an equation.
Y equals X.
Just x. Okay, so we start with y equals x is the parent function, and then we do stuff to it.
The stuff we're going to do is shift 5 units down. In or out of parentheses?
In, out. Outside of
If I'm going 5 units down,
left to right. Oh, outside.
negative outside. Okay? So, now I know that you have the whole 2 and 13. I'm going to say, did you have 2 with right? Did you have 13 with up? Did you have your parent? Was your parent y equals x? And then did you have the minus 5 at the end without parentheses? Okay? So something out of 5. Make sure you have those. There's a handful of you that keep just not turning in daily quizzes whenever we have our test and our notebook checks and stuff. Y'all, we're doing it right now in class. Just make sure that you write it down and you label it and you turn it in. Okay? What? Oh, dark ritual? Yeah.
It's one black.
Oh, I believe me, I know. For competitive metas, we actually use that to accelerate even in Commander. If I got to turn 2 Yargle, I'm smacking face. Okay, so we're going to move on to 3-7 then. Because if you got the whole transformation thing, the whole up, down, left, right, then this is just an extension of that. But it's a different kind of graph. What we did yesterday was lines and quadratics. Now, we're going to do absolute value. And talk about absolute value. Okay. I can't remember which class did what. Didn't we do absolute value equations in here first semester? I thought we did. Yeah, because then it goes along with our compound inequalities. I'm pretty sure we did. Okay, so tell me, what does this mean?
141. That it has. It means it's.
Boo!
It has to be.
Better. What does it mean? I mean, not wrong. He's out. Absolute value. Absolute value means distance from 0. Okay? If you need to write that up in that top right corner of this page, just because you don't remember, absolute value is distance from 0. And you should all remember this from geometric concepts, working with rectangles and triangles and stuff and trying to solve for things. A length measurement, well, if it's 11 miles from my house to the school, does that mean that it's negative 11 miles from the school to my house?
No.
It doesn't make sense, right? If I say that Chloe's 5'0",
What?
and I hang her upside down, is she now negative 5 feet tall?
No.
No. Not really. You're what, like 5'2"? Ooh. Dude, she'll Rochambeau you after class. Okay? Distance from 0 means that it's always going to be positive. I can't have a negative length. So that's the big thing. Distance from 0 has to be positive. So if I ask how far from 0 is 4? Well, 4 right here is 1, 2, 3, 4 units away from 0. But how far away from 0 is negative 4?
4.
Also 4. Okay, 1, 2, 3, 4 units. So that means we are going to start graphing these now. And it just means we got to keep that concept in mind that when I come out of the absolute value brackets, it has to be positive. So I want you to think about that on a graph, on a grid. Think about all your x's and y's. Think about your coordinates. Right here, what are the signs on the coordinates? Are the x's positive or negative? Okay. Are the y's positive or negative? Okay. What if I come over to this side? My x's. Ooh, right? Because isn't negative back that way on the number line?
Yeah, but it would still be.
Oh, no, when we do the absolute value, they will. And that's part of what I'm saying here. No, you're trying to jump the gun here. Okay. What about down here?
Negative, negative.
Okay. And here. So I want you to think about that. If I said, what is the absolute value of x?
25.
No. What if I put a 5 in there? I put in a positive 5. How far away from 0 is 5?
5.
So I would get a 5. But what if I said negative 5? What if I put a negative 5 in there? How far away from 0 is it?
5.
So then I get this coordinate of negative 5, 5, back 5, up 5. How far away from 0 is 2?
2.
So I'd have a coordinate 2, 2. How far away from 0 is negative 2?
2.
So I'd have negative 2, positive 2, and you keep doing that with all of your points, and it makes a V. So unless we take this V and move it up and down, it always points upwards. Okay? Now there's things called reflections where that V might actually head downstairs instead. Okay? Because now it's negative, so it points the other way, the opposite way. But the core of it is, because of this absolute value business, all of my graphs are going to be V's. Before, our parabolas were U's. You remember me saying you need so many points on there so they don't look like V's? This is why. Because I want a parabola to look like a U. I want it to have a little, all about that base. But these are absolute value. They need to be sharp and pointy. They're V's. Okay? So, base. All right. So, what I want you to write next to these is an absolute value will look like this. Again, they don't say this in our book, but I'm going to tell you. We're going to have H and K again. And they're going to do the exact same thing that they did last time. On Monday, what did H do with our quadratics? Left and right, bass-backwards land. So I want you to put that next to this. If it's positive, you go left. If it's negative, you go right. Just like with our parabolas. And the K, just like with our parabolas, it's outside of, not parentheses anymore, it's outside of brackets. And it's regular land. If it's positive, you go up. If it's negative, you go down. That is your holy grail right there. If you put that yellow, purple, and green thing like on a note card or a sticky note or writing on the back of your notebook and just have it next to you as you're doing the rest of this stuff, there's the lesson. Okay? I would like you to write next to this. Your vertex is always going to be at the point HK.
because we're going to take the pointy part of this V and we're going to move it left, right, up, or down. So look at their equation. It says +1 in the brackets. Left or right? +1 in the brackets. +1 in the brackets. It's going to go to the left one. So I'm going to take this whole honkin' V here and I'm going to move it left one. See how the pointy part went left one. That's my vertex. Vertex is the sharp corners on a picture, an image.
It kind of looks similar to like the where you point a laser at the mirror at an angle.
Yes. In fact, we use these to model those later. Then there's a -2 outside the brackets. Outside brackets, minus, tells me we'll go down 2. So I take that pointy part, that vertex, and move it down 2. And you see how the rest of it came with it. It still has the same shape. It just moved over here. Okay? So it's got a vertex at HK. If I shifted left 1 down 2, look at that vertex. It's now at -1, -2. HK. H is bass-backwards, K isn't. And then this section doesn't mess with the stretch for us. So I would like you to also put next to this that your slope on the right side is going to be 1. Well, remember y equals mx plus b? Slope.
Oh. Right.
So I'm using m to mean slope, and I'm going to put a subscript of r on there to say the slope on the right. Okay? The slope on the right will be 1. Because it keeps going up by 1, right? The absolute value of 4 is 4. Of 5 is 5. Of 6 is 6. Of 7 is 7. So it's always going up 1 over 1. Y'all, I need you to have that. This. Okay? That is your holy grail for how do I graph these things. Yeah, I've got some. Anyone else?
That, because I'm Sharpies I could use for colors.
Yes, no? Yes, no? Yes, no? Yes, no? You got 1,000 colors over there. Yes, no?
No thanks.
Okay. Yes, no?
I'm good.
Yes, no?
Sure. No, thank you.
Okay.
Sharpies.
You robbing Office Max? Okay. Yes, no? Okay. Just wait for it. Going to get a call. Send Kevin to the office. Officer Gillette would like to speak with you. Okay. All right. So everyone's got those. Well, you should have it on your paper, right? So, here we go. Round 1. Graph the absolute value function, absolute value of x plus 1. So they said start with the parent function, and they already have it there for you. What are we going to do to that? Are we going to go left or right, up or down?
One up, because it's outside of the
Okay.
lines and it's positive 1.
I see +1 outside, and that little cheater chart still works here, where if I'm talking about the parentheses, plus minus in, out, except now, instead, it's not parentheses, it's brackets. And it's still going to work. Left, right, up, down. It still works. Okay? So that little, that formula version I gave you, and this cheater chart, that'll get you the whole section. That's how we graph these things. So I'm going to shift this whole thing 1 unit up. That means every single one of the points that you see, this point, 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 all of those, take every one of them and move them up 1. Connect the dots. That's where our graph is now. Okay? So make the graph. We're going to take our vertex and move it up 1. And you notice on the right side, up 1 over 1, up 1 over 1, up 1, right 1, up 1, right 1. Or on the other side, we mirror that. The slope isn't going to head back down. These are V's, not lines. So they're going to mirror across. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Okay? That's it. That's how you graph these. Now, I hope that you are okay with moving a parent graph around, because the alternative, y'all remember this? Do you really want to keep writing that over and over? Because that's what's coming. If you can't graph this by transformations, then -2, -2, absolute value of -2 is 2, 2 plus 1 is 3. -1, absolute value of -1 is 1, 1 plus 1 is 2. Absolute value of 0 is 0, plus 1 is 1. Of 1 is 1, plus 2 is, or plus 1 is 2. 2, 2, 3. I don't want to make that table every time. If I don't have to make the table, I'm not gonna. I would rather just move that thing up. Okay? It's up.
So for the graph, is there a version about that where it's like dotted and solid lines version of that?
Eventually, yes. Not today. Don't worry about it. It does not exist. Don't worry about it. Okay. Flip it over. Now they're going to do multiple things to us, and they're not going to give us the parent graph to start with. So, talk about this guy first. What's that doing?
Right 1 and then down 2.
Listen to the Paxton. It is 1 unit to the right. Remember, it's in the absolute value brackets. It's bass-ackwards land. Okay. And there's a -2 on the outside. So we're going to go 2 units where? Okay. So this is where the vertex would have been, right? Smack in the middle, 0, 0. I'm going to take that point. Everyone follow with? I'm going to take that vertex and I'm going to move it 1 right, 2 down. And now, on the right-hand side of it, I'm going to use a slope of 1. Okay. up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. The slope on the right side will be 1. We're not monkeying with the stretches yet. Okay? And then we mirror it. So we don't keep going down this way. Then instead of saying up 1, right 1, we're going to say up 1, left 1. Because it was 1 to the right, we're going to go 1 to the left. This was 2 to the right, we're going to go 2 to the left. Mm-hmm. So up 1, left 1, 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 up 1, left 1. And I got me a V. Connect the dots. Chugga, 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 choo. There it is. Okay. So we use our transformations, our up, down, right, left business to find out where the vertex is, and then you just make the V from there.
So you don't want us to make the V?
Nope, you don't have to do the parent unless it tells you to. Example 1 said to use the parent graph because it's easy to move those points. But if we just use a slope of 1, I think we're going to be fine. Yes or no? Okay. So both of these say start with a parent function. I'm going to put the parent functions on there to help you start because look at the graphs. They went by 2's. Okay. So the parent graph starts at 0, 0. But hey, if I go up 1 and right 1, can't I go up 2, right 2, and it simplifies to the same thing? So I can still make my dots like this. And then I mirror them to the left. Like so. That's the parent graph, then we're going to move it. Okay. I start with a parent graph. And then I'm going to move it. I would like you to shift the parent graph however far they're saying in whichever direction they're saying. I want you to move that purple V somewhere, preferably in the right direction. I should say in the correct direction. All right. You'd think that. You'd think that. Is there?
Be like that correct.
There you go.
And then
It's outside.
outside, so it's just 2 units up, correct?
Yes.
Okay.
There you go.
I regret saying that since I'm already stuck.
I have to make the distinction between right and correct because I just had that argument with my 4-year-old.
Yeah, I don't know what you mean by that.
Okay. So you started here.
Right.
You said you're going to go 5 right, and you are correct about that. So take this point and move it. 1, 2, 3, 4, 5. Take this point and move it. 1, 2, 3, 4, 5. Take this point.
Well, I am brain dead.
No, you just made a goof. It happens.
Yeah.
Take all of these points and slide them over 5. Take all these points and slide them up 2. That's it.
Alright.
And the other one.
Oh, the other.
So, I believe this is all the
I-
stuff that I have missing.
What?
I think this is all the paper I have missing. I need to do the daily quizzes still.
Okay.
These are the pages I should be missing.
Okay. These are from week 1. I can definitely put these in. We also had stuff in the packet. You should have everything up to this point done. And there was one handout for week 2. Have you done this?
No, I don't think I did.
Okay. So that, and then up through
Progress check.
the progress check 2. What?
Never mind, it's bribery. Never mind.
I mean,
Does it go up to?
yes.
Okay.
I am a teacher. They pay us in peanuts and insults.
Anything else?
No, I don't like Taco Bell.
This one. Hold up. This one, right? This way.
Correct. So,
Please use the restroom.
dude. Oh, I'm sorry. I gotta change dialect for generation. Bruh. You didn't do the thing yet.
I don't know how to do it. You're helping someone, and this is like an absolute emergency.
Go.
So the 3.3 homework packet is this to the stop sign, I'm guessing.
Yep.
Perfect. And then I already know where the other one is.
Okay, it looks like most of us either got it or we're just finishing our last one. If I got a -5 in the brackets, we go 5 units to the right. So I take this point and move it right 5. Then I take this point and move it right 5. And take this point and move it right 5. And that point and move it right 5. And that point and move it right 5. And that point and move it right 5. You could say that I like to move it. Okay. And then the other one's the same deal. Now, I saw a few of you didn't move the parent function, you just graphed where it's going to be. And that's okay. If you know that this thing is going to be 2 units up, because it's a 2 outside, you can just graph your v right there. Okay? In fact, these two want us to graph the parent function and then move it, but if you're cool just graphing it there, I'm fine with that. Okay? So, what even are those, Dylan? They're like, oh.
They're cutting sticks.
He's trying to bribe me with food. I don't even know what it is. Cinnamon. Oh.
Cinnabon delights.
Oh. Okay, that does sound good, but Taco Bell just scares me. I was also afraid that they were the fried cheese curds, like. I won't even do mozzarella sticks after a particular gas station in Iowa destroyed me. All right. Here we go again. Now we're going to do 2 things at once. Start inside. 6 units to the right. And because this is outside of the brackets and it's negative, 1 unit down. So normally I would have a vertex starting right here. Be very careful about your scale. Look at what they're doing. Your Y's are going by 1s, but your X's are going by 2s. Be careful. I'm going to take this point and move it right 6, down 1. So if you had done points like this, you see how you'd be wrong? Okay, the x-axis is going by 2s. So to the right here, I'm going to go up 1, right 1. Up 1, right 1. Okay, the x-axis is going by 2s. So you're only going to move half a box at a time. When I go in the left, up 1, left 1. Up 1, left 1. Up 1, left 1. Left 1, left 1, left 1. You see how it ended up looking skinnier? But it was just the scale of it. Like a funhouse mirror for graphs. Okay. Connect your dots. You got a graph. Now, I remember in the past I had some kids who were mad that the V's weren't all symmetric like that on the graph that it shows. Like, because it looks like this, it just bothered them so much. Like, no, the entire V is there. It's just that's how much of the graph is showing. Okay? It's like when you take a really bad picture of someone and you got like half of a person's face off to the side. Okay? It's not like they just look like a third of their skull is missing. It's just they're not in the picture. Okay? So, I think we're doing all right here. Let's try again. Those 4. You don't have to do the parent graph this time. If you don't want to. I know it says graph the parent function. You don't have to. If you can go straight to where this V is, you're fine. Get them? Yeah. Okay. So we always start with a V at 0, 0. And then on this side, the slope is 1. On this side, I'm just going to mirror it, but I'm going to go left. Okay. So that's the base form. Then, here's our little cheater chart here. Around those brackets, if I have something that is positive or negative, something that's inside or outside. Anything that's inside is bass-ackwards land. If they say plus, you're actually going left. If they say minus, you're actually going right. And the idea is, think of this as like, it's going to take so many weeks for you to save up for your car. Well, what happens if Grandpa gives you a birthday check worth 6 weeks of pay? Aren't you closer to your goal? So that's why it has an opposite effect. This tells me I'm going to move 6 units to the negative inside to the right. Okay, use this. This is a negative 1, so I'm going to move 1 unit. It's negative, and it's outside. These are up and down. So negative outside, I'm going to move 1 unit down. So this point that would have been here, I'm going to move it 6 right and 1 down. 2, 4, 6, down 1. And then I'll use my slope. Watch your scale. See how they're going by 2s? Up 1, right 1. Up 1, right 1. Up 1, right 1. Oh. Okay, that should have been like halfway. Here we go. Up 1, right 1. Like this. Okay, and then mirror it. Up 1, left 1. 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 So it's going to look skinnier than normal, but that's just because the scale is squished in. Okay, use that chart. This is your big mamma jamma. Okay, and then slope is 1 on the right. Cool?
Yep.
Show me. Okay, I'm not going to make you do this part.
To inside to negative, so right.
There you go.
And to negative, it's outside, so down.
There you go. Okay, so put your first point, your vertex.
Right. Down.
There you go. Then make your stairs. There you go. Mirror it to the other side. Nope. Mirror to the other side.
Oh.
And I swear, that happens all the time. I'll even do it. You're just so used to making lines.
Yeah.
There you go. And then shoop shoop. This is how we do it.
Wait, but then what do I do with this one since there's no, just the same thing? But...
Since there's nothing outside,
Okay.
nothing outside, that means it won't go up or down.
So just stay at 1.
So I will just use this.
And then that's 1 inside left.
1 to the left.
1 unit left. So,
There you go. Got it. You got this, bud.
Honestly, this one's like, I wish I was sleeping right now.
Wake up!
Scared me.
I just want to help you, bud. I want you to be your best self.
I
Okay?
worked a little ahead.
But you got it. You know what you're doing.
Looking right.
Okay. Oh, these ones on there. Okay, 2, 2, 2 right, 2 down, thump, thump, 1. Ta-da! Got him. I'm sorry, Shane. I didn't mean to make you piddle on my floor. I'm sorry. It's okay. Oh, don't do that to dogs. That's mean.
2 weeks ago,
Oh.
he got in the garbage, so I went on the ground, and I was like, did he do this? And then he got scared himself. It's the best part. I got everything.
Yeah, but Pitty's got a bad reputation because people are mean to them. They're actually, like, very loving animals.
It tries to be. Okay, but
No, not gonna do it yet. Not gonna do it yet. Are you done? Wait. Is it inside or outside?
Inside
So,
means
where's your teeter chart?
I was asleep,
I noticed.
so wouldn't it be like right or what?
Yes. Okay. Have it next to you so you don't have to keep flipping back and forth.
if it's an X outside, is it just 1 or is it 0?
Well, if there's no other numbers with it, it didn't move right or left. Okay, so if I have a plus or a minus that is inside or outside, inside says left, right, whether it's positive or negative. Outside says up, down.
So that would be left.
Okay. Okay, have that next to you. Okay, so start by making a point 1 to the left.
And then you go up 1 right.
And then the slope on the right-hand side is up 1 over 1.
It's just working on that. It's gonna take my mom back.
Okay? And then you mirror to the other side instead of keep going down. There you go. What? Okay. Yep. See, Geneva knows what's coming. I was about to start writing things and then I stopped myself. You know why. Volunteer or get drafted. Geneva, you want number 9. Okay. In the words of the youth, get it, girl. Okay, 2 units down because it's a negative on the outside. Use that cheater chart. And then slope on the right-hand side is 1. Good, good. Mirror to the other side. That was such an ominous, like, scratching noise. But, yes, killed it. All right. Micah, which one do you want? Okay. Let's see if you can work the board. You've seen me do it 1,000 times.
I know how.
You gotta click that magnification thingy at the top. No? Maybe not.
No. Okay. Go 5 buttons to the right of that. The one that shows a page with arrows showing, pointing out in all directions. Poke that. Now, do the magnification thing on 8. You have to go left to right before up and down. It took me and 2 tech guys several hours of cursing to figure that out. Because if you go up down first, it scrolls pages instead. Yeah.
So since it's in parentheses, we have to go to the opposite. So
Yep. 1 to the left.
that about parentheses? So 3.
Okay. So,
Come over here.
And then once you're done, don't erase.
and then use our slope of 1 and -1 on the different sides. Connect the dots. We got a V. Okay. Yes. Okay. Volunteer or get drafted. Kevin wants in. Riley, you want the other one?
I call next.
You cool if Riley does 7?
Sure.
Okay, so you'll do 6.
Wow. Oh, I forgot
I call
to
that
bank
sold.
it.
No. Left to right first. There you go. No joke. Y'all know Tony and John down the help desk?
No.
Every time Tony touched this, it worked just fine. Every time me and John touched it, it would scroll pages and we'd just start cussing up a storm. Like, it was a couple years ago when we got the Windows 10 update. Sure, you do whatever you want, bud.
And then don't erase. Wait, never mind.
Well, you got to say your stuff. Okay. So there's a pair of 2s, and they're both negative. It's just where they are determines what they do.
Let's put the instead of words.
Arrows work too. Sometimes that's a better visual cue for us. Okay, 2 to the right, 2 down because of where they are. Nailed it. Don't erase.
You can. Forgot I already had that one.
Oh, okay.
This is my first time all year being at the board. What?
Get them. Yeah, I know, because you always go in the bathroom when we're about to start doing this.
That's true.
All right. Yep, you poke the full page button. You're on the magnification. Left to right first, then down. All right. Get them. Okay. Okay, left one. Use our slope. And then, honestly, I think the toughest part of these is going to be remembering to mirror instead of just keep making points down to the left and accidentally make a line instead of a V. He doesn't have to.
I'll have to pass on that.
Man, why? Kevin back here, like, heckling peanut gallery style. Okay. All right. No, y'all did great. So that's good. That means we know what we're doing.
Literally all you
Wait, we already did all 4 of those. We did all 4 of those. Okay.
now it's a free day for the rest of it.
I want to do one of these 3.
Thanks for waking up.
Nice hatching, Mike.
Smooth. I want to do one of these 3 because they all have very different scales, and we need to pay attention to scales. I want you to look at them and tell me which of these 3 should I do. 12? Okay. And 12, they're going by 2s in every direction. Okay. Whoop. There we go. That's better. So, start with what do? Left 3. You know, and there's nothing wrong with just right next to it doing exactly that and just putting arrows that tell yourself where it's going. Okay, left 3 and down 6 because of where their respective values are, inside or outside, positive or negative. Left 3 down 6. You got to be careful. That dot's going to be right smack in the middle of the line. They're going by 2s. So when I count my slope, up 1, right 1, it's going to be half boxes instead. Okay? So up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And after you do a few of them, you start to get the pattern to it where you don't even have to count. It's just I'm going in this direction, and every time I hit the line, I make a dot. Up 1, right 1, up 1, right 1, up 1, right 1. Now, I didn't have to make all of those dots because my scale is 2 and 2. My scale is the same. I could have instead gone up 2 over 2. Up 2 over 2. Up 2 over 2. Okay? In fact, if the scales are the same, you can do whatever you feel like as long as they are the same. What if I did, instead of up 1 over 1, how about up 5 over 5? Up 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. Up 5 over 5. Up 5, 1, 2, 3, 4, 5 over 5. Okay? They're still going to be on the same line. I don't care how you do it, so long as you're still in that same proportion. And then connect dots. And then every one of you who comes up here, you realize how annoying it is to try to make a straight line on a smartboard.
I already have to look back.
Okay?
Oh,
So the two above this and the assignment thereafter.
Whoa. Wait, we have to.
It's pretty obvious that you all know what you're doing. So number 10 through the end, 10 through 23, you got this. Y'all know what you're doing.
I already got 10 and 11 done.
Okay? 10 through 23, you got this.
Brett, come on.
So wouldn't it behoove you to get this done now and in Spartan time so you don't have to think about it again until Tuesday?
No.
Yes.
Just saying.